Hey, and good evening. It's Programmers Live once again. Thank you for watching my programming episodes. Hope you're really benefiting and you're really looking towards becoming a good programmer in a number of frameworks, in a number of languages, with a number of tools. So if you really enjoy these videos, don't forget to subscribe to my YouTube channel, and that is Programmers Life. So back again from where we ended last time. From the previous episode, we had started talking about operators, and if you recall, for those of you who have watched the previous episode, we ended with logical operators, and we said we have the or, we have the not, and we have the and. So we ended with explaining how each of the operators truly operates. So we shall begin with an example. Take the example is below. Okay, let's zoom a bit. Take the example is below. What if I have a negation 20? Without forgetting, our syntax is, so what if we have a negation 20? Definitely this gives a 0. Why does it give a 0? We are asking, it's a form of querying, then asking it's not 20, then of course if it's not 20, then it's some other number. Okay, so this means it will give a false, because we said the negation operator and the logical operators, it defies what is already in existence. Then assume we had 10 and 5. Assume we had 10 and 5. What does this give? It gives 1. Okay, 10 and 5, so definitely that will give 1. Assume we had 10 or 5. This gives a 1. Okay, assume we had 10 and 0. Assume we had 10 and 0. Of course this gives a 0. So basically we are picking this concept from what we called Boolean logic. Now I know some of you are still confused about how this really operates, so maybe let's have a truth table. It's called a truth table. So in a truth table, using Boolean logic, it says if we have n inputs, then we shall have n to power n to get the number of outputs. So what does it mean? It means if I have 2 inputs, then it will be 2 to the power 2, and 2 to the power 2, this equates to 4. What do I mean? I have a sorry about that, I have a, then I have b. Okay, those are my inputs. So with binary logic, it means that there is a possibility that a can be 0, there is a possibility that a can be 1. Okay, then there is a possibility that if a is 0, then b can be 1. there is a possibility that if A is 1, then B can also be 1. There is a possibility that A can be 1 and B can be 0. There is a possibility that A can be 0 at the same time and B can also be 0. I think they are exhausted. Now, what we are checking out is this. We can say A or B. Now, if we say A or B, remember we said that it is only and only false when both are false. Okay, that is A. That is O. Then I told you O can mean that is binary addition. Okay, so it means that if we have a false and a true, then we are going to have a true. If we have a true and a true, then we are going to have a true. Okay, if we have a false and a true still, then we are going to have a true. Then if we have a false and a false, still we are going to have a false. So it's only and only false when both are false. How about if we have A and B? We said if it's AND, then what does it mean? It means that it is only and only true when both are true. Okay, otherwise it's a false. What does this one mean? I can give an example that if you're logging into your Facebook account, if you're logging into your Gmail account, for example, it means that you can only and only log in when both your username and password are correct. Okay, it's only true when both are true, otherwise it is false. The other false bit of it is if my username is correct and the password is not okay, then I will not log in. If my password is correct and my username is wrong, I won't log in. So both have to be true for the account to be accessed. So it's only and only true when both are true. So this time around, what is going to happen? We are having a false and we are having a true. It is only true when both are true. Okay, so definitely this will mean a false, this will mean a true, this will mean a false, and this will mean a false. Okay, that is A and B. Now, what if we had not A or B? What if we had not A or B? Without forgetting, we already have a column for A or B. So it means if it's not, we said it's a negation. So if this is true, then it's gonna be false. This is true also, so it's gonna be false. This is true also, so it's gonna be false. Okay, then this is true, this is false, so it's gonna be a true because it is not A or B. So the same applies to not A and B. Okay, what does this mean? It means that we already have a column for A and B. So this is false, automatically it's gonna be true. This is true, so automatically it's gonna be false. Okay, then the same applies to this one, is gonna be true. Then the same applies to this, then it's gonna be true. Sorry about that. Are we together? So that makes a perfect understanding of those logical operators. Don't worry, we are yet to have as many examples as possible as we move beyond this. Now in the next bit, I think that was number 4, let's try to look at some special operators which are called bitwise operators. Now these ones are not so common in our usage, but it doesn't harm if we talk about them in this case. Now bitwise operators perform operations on integer data. They perform operations on integer data at individual bit level. Now that is why we call them bitwise operators. So for them, they handle in form of bits. Okay, now they include a number of them. Among them we have the bitwise AND. Okay, we have the bitwise AND, we have the bitwise OR. Notice the differences. The other side, when we are using AND in the logic operators, we use 2 ampersands. Okay, like you note up here. But if it's bitwise, then we are using a single. Then when we are using logic operator OR under bitwise, we are using a single pipeline symbol. Okay, so then we have a bitwise exclusive OR. This one is called exclusive OR. Okay, just to make life simple for you. Then we have a bitwise complement operator. A bitwise complement operator. Complement operator, for those of you who have done some bit of math before. Then we have bitwise shift operators, that is left. Okay, these are left. Then we have bitwise shift operators right. We have bitwise shift operators right. Don't forget, we've said these perform operations on integer data at individual bit level. Okay, so these operations include testing, setting, or shifting what we call octobits. 4 octobits. Now octobits, that means that we are handling what we call base 8. Okay, when we're handling bits but under base 8. So that is where we truly need to have what we call bitwise operators. Why would you need them? Because you're handling testing, you're handling setting, you're handling shifting of bits at that particular level. Now these operators are necessary because when we are programming, remember I told you last time, the computer uses the brain, which is called the CPU, and inside the CPU we have quite a number of parts. Among them we have the CU, which is called the control unit. Among them we have the registers. Then we have the ALU, arithmetic logic unit. Now this is where emphasis is taken. So these operators are necessary because the ALU, okay, in the computer's CPU carries out arithmetic operations at the bit level. I'm saying it again. These operators, or the bitwise operators, or the bit level operators, which do the testing, the shifting, and all that we've talked about, it works specifically when it comes with the CPU. And I've told you the CPU has its major part, which is called the arithmetic logic unit. What does it do? That is where all computations occur. Now it works at that level because the ALU carries out operations in form of bits altogether. So what we need to know is how each of them operates. Okay, is how each of them operates. Now we shall begin with the bitwise AND. Okay, hope guys we are moving together. Now we are going to still use a truth table. So I'll have A like we've done up there, then I'll have B. So the number of inputs that I have are 2, so the number of outputs are going to be 4. Reason being, we said we are following the principle that if we have n inputs, then we shall have n to power n to get the number of outputs. So we gave an example. If we have 2 inputs, then automatically it's gonna be 2 to the power 2. If you do that simple basic math, then definitely you're going to get 4. So we are still using the same principle, and we need to know how does a bitwise AND operate. So for this case, we shall assume that if A is false and B is false, if A is false and B is true, okay, we need to exhaust them. Then if A is true and B is false, then if A is true and B is true, I think we have exhausted that. So what are we checking out? Don't forget, sorry about that, we are checking out if it's A bitwise and B. This time around it's not a logical AND, but it is a bitwise AND. Now remember, under logical operators we said AND means it's only and only true when both are true, otherwise it is a false. That is why I gave you an example of logging in. Both credentials should be okay for you to log in. Now for this time around it is the same concept. So this one is gonna be a 0, meaning it's a false, a false, a false, and a true. So how easy that is. Now together, that is what we call a bitwise AND. Okay, that is what we call a bitwise AND. Okay, now once again, let's try to look at what we call the bitwise OR. Let's try to look at what we call the bitwise OR. Now in the bitwise OR, we shall take the same concept. We shall have A OR, that is bitwise OR. So what is the process, or what is the concept there? So it's only and only false when both are false, otherwise it is a true. So definitely here we shall have a false, and here we shall have a true, and here we shall have a true, just like the way we had it in the previous truth table for the logical operators. And here we shall have a true. Are we together? Are we together? So definitely there. Then we have what we call exclusive OR. We have what we call exclusive OR. So exclusive OR, I'll have A exclusive B. I'll have A exclusive B. Now here someone should not get confused. Exclusive OR, listen to me very well. Okay, it is false when both are false. It is false when both are true. Otherwise, it is true when any of them is true, or when any of them is false. Okay, how does it work? Let's write it here. We shall say it's false when both are false, and false when both are true. Okay, I'm trying to make it a little more understandable. So when is it false? It's false when both are false, and it's false when both are true, but true when any of them is false or true. So what does it mean? Now it means that these are both false. Okay, those are both false, so it's gonna be false. Now these are both true, so it's gonna be false. Guys, I'm talking about bitwise operators. Now when it comes to A, B, now it's the B that is true, so it's gonna be true. Then it is the A that is true, then it's gonna be true. So that is how basically the exclusive OR works. Guys, are we okay? Are we moving? You can watch this episode as many times as you want, but focus on listening as you are watching. Now together, then we have what we call the complement. Now the complement is a negation. The complement is a negation. So complement, we said we use that symbol. That symbol is going to appear again in the future when we are talking about something called destructors. But for right now, under bitwise operators, let's allow it to take that outlook as being complement. Now consider we have a number like 1 1 1 0 1 0 1 1. Assume we have a number like that. Now a negation of this number, a negation or a complement of this number is definitely as below. Up there it is true, then it's gonna be false, then it is false, then it is true, sorry about that, then it is true, then it is false, then it is true, then it is false, and it's false. That's what we call a complement. Okay guys, I said whatever you see here ain't enough, so in your free time try to make as much research as possible. So for starters, in today's session, my first assignment is going to be, let guys look out for the two shift operators, that is left and right. So in your free time try to look out for that. So for any questions, of course you can always reach me out on my Gmail account, that is programmerslife@gmail.com, or reach me out on WhatsApp, that is 0751824973. If you're watching this video and you're not from Uganda, then of course you use our code +2567518249773. okay, so don't forget that. Now another type of operator, definitely this has to be up there. We had 4, then 5. Now we have some other special types of operators. We have what we call the increment and decrement. Now increment, this is how they move. Then we have decrement, that is how they move. So it's a pair of 2 plus signs and a pair of 2 minus signs. Now these are called auto increment and auto decrement. Okay, now auto increment means auto increment means add 1 per execution round. Okay, add 1 per execution round. Then auto decrement means deduct, remove 1 per execution round. Okay, each time an execution occurs, then you either add or you remove. All together. Now these two are categorized into two ways of operation. One, we have what we call postfix. Each of them has what we call postfix, and each of them has what we call prefix. Now, post means after in a layman's understanding. For those of you who are always bothered with these complex things of English, so postfix means after, then prefix means before. Okay, postfix after, then prefix before. What does it mean? It means that when it comes to increment, I can have a postfix increment and I can have a prefix increment. When it comes to decrement, I can have a postfix decrement and I can have a prefix decrement. Now, the difference is significant. When you use a postfix form, the operator is first applied and the outcome is then used in the expression. I'm saying it again. If you use in a postfix way, okay, the effect of the operator is applied. If it was evaluation, of course, or execution, whatever the case may be, the effect of the operator is applied and then the outcome is used in the expression, and then the outcome is used in the expression. Are we clear? But this is applicable in a continuous execution. This is applicable in a continuous execution. Sometimes you can have an expression whereby execution is going to occur once, then this rule does not apply. When does the rule apply? The rule applies if you realize that a certain variable that is subjected to a postfix, okay, either an increment or a decrement, okay, is going to be seen in that form of execution. Are we clear, guys? So we are moving out together. Then prefix, we said in a layman it means before. Okay, in a layman we said it means before. Members, I don't know if it is really clear. I know these operators really more so if you're just starting programming, they really make life hard. Once again, I've said post means after, and I said, of course we are going to have examples. I said if I have a variable for that case and this variable is subjected to postfix, and this variable is in a continuous execution, meaning that I need this variable ahead of the execution quite a number of times to come. So what does it mean? It means that the result of the operator is considered in the next execution, but not immediate. Okay, I'll explain that back again. Now, if it comes to prefix means the operator is first applied, okay, and then the result or the outcome is used in the expression. Are we together? So here it means take the effect and then use. Okay, take the effect and then use. The effect of the operator is applied. Okay, so for us to understand this very well, let's try to have some examples. We can say given a is 2. So if I say a plus plus, this means a is assigned a plus 1. Okay, otherwise if I say a minus minus, this means a is assigned a minus 1. So that is why up here I said add 1 per execution round or remove 1 per execution round. Altogether. So again, in the understanding, if I say a plus plus, this is post. Then if I say plus plus a, then this is prefix. Okay, now in a continuous execution, this means use the variable, then take effect in the next execution. Now I'm summarizing if you never understood what I said previously. So use the variable, then take effect in the next execution. Otherwise here, take effect first, then use the variable. Okay, when is this done? Under a continuous execution. What do you mean by continuous execution? Example, I say I have a variable called int my var. I have a variable called int my var, and it is initialized to 5. Okay, I'll comment and say variable initialized to 5. Okay, hope you remember how we use comments. So variable is initialized to 5. So what is going to happen? Then I'm going to say evaluate. This is a form of what we call continuous execution. Continuous execution means that the variable continues to work in the next statements of execution. So it means that is where the rules are going to apply. So assume it is a prefix increment of my var. Then assume it is a prefix increment of my var plus 10. Are we together? Now we have said in a continuous execution that take effect then use the variable. So if I take effect here, it means that if my var was 5, then here I increment it by 1, so it's gonna be 6. So 6 plus 10, of course this is going to give us 16 altogether. Then what if I have my var postfix increment then plus 10? What if I have my var postfix increment plus 10? Okay, postfix increment plus 10. So assume this is separate. Okay, in that form, then we are having another one. So still considering the same, if it's a postfix increment, then it means that we shall first use the variable, okay, then take effect in the next execution. So what does it mean? It means that if we still consider the value of 5 in my var, then plus 10, definitely this one is gonna be 15. Hope guys we are okay. I'm really giving this a lot of time for guys to understand. Then assume it is a prefix decrement of my var, a prefix decrement of my var plus 10. Assume it is a decrement of my var plus 10. Then automatically, if my var was 5, then a pre-decrement, we are taking effect, then use the variable, then definitely it is 4. So what shall we get here? We shall get 15. Once again, in another example, I can say it is my var, okay, it is my var, a postfix decrement plus 10. Postfix, I told you, first use the variable, then take effect later if at all it's needed. Okay, now what is going to happen here? It means that if my var is 5, then I'll leave it to a 5. So plus 10, definitely it's gonna give me 16. Are we moving? Are we moving? Now let me assume it's a continuous execution in the application. Assume it is a continuous execution in the application. I'll copy and follow it down here. Now still using the same concept, it was int my var and it was initialized to 5. So we are following a continuous execution. I want to show you how all the rules do apply. Now definitely if it is a pre-increment of my var, then this one is gonna be 6 plus 10, then it will be 16. Now once again, by the time we leave this line, that is line 105, then we enter here, then it means my var is 16. We're handling a continuous execution, so it means my var will move with its previous value into the next line of execution, that is line 107. So here if we have 16, okay, then it means that we are going to use the 16 before we take the effect. We are going to use the 16 before we take the effect. But as we leave that line something else will happen. So it means my var at this level is gonna be 16. So it will be 16 plus 10, which is gonna be 26. Guys, we are handling a continuous execution. Now at line 107, my var, we assume, because it's the one that we are giving a 10, so we assume it is 26. Actually, not assuming, we are sure it is 26. But remember, as we leave, then this post increment takes an effect. So it means that my var, which was 26, it's gonna be 27. So if it becomes 27, then it reaches line 109. Then since it is a pre-decrement, it is going to lose the value. So instead of having 27, it's gonna be 26. So it will be 26 plus 10, which is gonna be 36. Guys, are we moving? So it's gonna be 36. Now, it being a 36, as it leaves this line, we don't have any either decrement or increment operator in a postfix form. So we leave line 109 when my var is still 36. So 36 as my var enters line 111. Okay, so it means that will be 36. Then we meet a postfix decrement, okay, which means that will take execution in the next line or in the next round of execution. So it will be 36 plus 10. Definitely this is gonna be 46. So ladies and gentlemen, if you are watching this episode, hopefully you're really understanding what we call increment and decrement operators. So for right now, allow me sign out. We shall continue from there next episode.